All right, so I'm going to do 3 problems of this challenge integer one. Okay, so what makes this difficult is the fact that you don't have to choose one answer, you have to choose 2 answers. So the very first thing I do is I simplify it, and I'm allowed to add those exponents together. That's 7 to the power of 4. So all I'm looking for is 2 answers that equal 7 to the power of 4. All right, so here, if I choose answer choice A, if I do 2 minus a negative 2, because that's a quotient property, that becomes 7 to the power of 4. So that's one of my answers. Here's a power property. If I do a power to a power, that becomes 7 to the power of 4. So that's my other answer. Okay? And so B and C are not correct. All right. It says right here, which expressions are equivalent to 1 over 5 to the multiplied to itself 4 times. So you could say 1 over 5 to the power of 4. You could say 1 over 5 to the power of 4, but that equals 5 to the power of negative 4. Power to a power, that's 5 to the power of negative 4. If you do 4 times 0, negative, that's not it. That becomes 5 to the power of 0, so that's not it. If I do 1 minus 4, that's 5 to the power of negative 3, so that's not it. And if you can't hear me talk very well, that's because my class is just loud. And 2 minus 6 is negative 4, so that does work. So I'm going to go A and D. So just so you guys know, 1 over 5 multiplied to itself 4 times is this, which is the same as this, which is the same as this. So I'm going to highlight your equivalent expressions. This expression is equivalent to this expression, which is equivalent to that expression. They all mean the same thing. Okay. Now, this one's a little bit tricky, okay? Because we have 2 to the power of 5 over 6 to the power of 5, okay? So that's a little bit tricky because we have to kind of break things down. Does anybody know what 2 to the power of 5 actually equals? It equals 2 times 2 times 2 times 2 times 2. And 6 to the power of 5 actually equals 6 times 6 times 6 times 6 times 6. Does anybody know what 2 6 will always reduce to? 1/3. So if I end up canceling all these out, like this, what do those all reduce to? 1/3. Okay? So I have, but here's the thing. That's a 1. That's a 3. 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 How many 3's are actually being multiplied? 3 to the power of 5, which is the same as 3 to the power of negative 5. So 2 to the power of 5 divided by 6 to the power of 5 actually becomes 1 over 3 to the power of 5. So that's one of my answers. Okay. If I ever want to make a negative exponent positive, all I got to do is shift it up or shift it down. So if I shift that up, that's 6 to the power of negative 5. There's your other answer that works. So B and D are your 2 correct answers. Okay. All right, take a look at this problem. Natalie tried to evaluate this expression. Oh, by the way, Natalie took way too long to do this problem. I don't know, somebody who doesn't know what the power of 0 means. Does anybody know what any number other than 0, any number raised to the power of 0 always is equal to? No, it's not equal to 0. Yes, so it's equal to 1. Look what happens. Would you guys agree that in your bank account you would like to have, hold on, would you like to have this in your bank account? Yes. Look, if I wanted to make that equal to 1, I just raise it to the power of 0. Boom, 1. If I make a negative, let's say you were in debt, and you're like, oh, I don't want to be in debt. Just raise whatever that is to the power of 0. It's equal to 1. That's what I was saying. Natalie, really, that's just going to equal a 1. But where did Natalie go wrong? Well, she went wrong right here. I'm sorry? That's not the answer. Step 1's not the answer. Well, let's see here. Let's see here. 4 to the power of negative 3 times 2 to the power of negative 3. All right. If we factor this out, it becomes 4 times 2 to the power of negative 3. So that could be 8 to the power of negative 3. So yes, I guess that could still work. So step 1 could work. Okay? And power to a power is 8 to the power of 0, so that would work. So step 3 is where that should be a 1. But all I'm saying is this, Natalie, just seriously, just whatever that is, raised to the power of 0 is 1. You don't have to do any work. Like, you did way too much work for nothing. So that's why these problems sometimes tick me off, is because she didn't have to do all this. Like, that right there to the power of 0 is 1. So yeah, she did a lot of good work just to make the mistake on step number 3. Okay? All right. So here we go. 4 to the power of negative 2 times 7 to the power of negative 2. Well, that's easy. That could become 1 over 4 squared times 1 over 7 squared. All right. So that's one way of looking at it. So it could be 1 over 4 squared times 7 squared. Okay. Now, if you kept this one in the, by the way, what does this mean? 4 times 4 times 7 times 7. What's 4 times 7? 28. What's another 4 times 7? 28. That could equal 1 over 28 being squared. So there's one of my answers. And then if you kept this one in the numerator but moved the other in the denominator, you could rewrite it as this. If you move this down, that would be another answer that would work, that these are equivalent. Now, if you have calculators, you can literally type them in and see which ones they are. If you just type them in. Okay. All right. Let me pause it. Actually, just what's your question? I have a student ask me a question. She says it's one of these, which I don't know what one of these are. Okay, just tell me what it is.
Chris tried to rewrite the expression parentheses 4, negative 2
Okay.
times 4,
Okay.
negative 3,
Like that.
parentheses
Okay. 3. Now, if he wanted to, you could actually add those exponents together, and you could get 4 to the power of negative 5 if he did that. Did he do that?
Yes.
He did that. So that works. Okay. Now, if you multiply those power to a power, what does that become? 4 to the power of negative 15. Did he do that? Oh, so he messed up in step number 2 is where he messed up. Okay. All right. So now we do this problem. What does that mean? 1, 2, 3, 4. 1, 2, 3, 4, 5. That's 7 to the power of 6. So we just have to find another answer that equals 7 to the power of 6. Well, what's 8 minus 2? 6. What's 6 plus 1? 7. What's 2 times 3? 6. What's 12 minus 2? 10. So which are the only ones that equal 7 to the power of 6? This one and this one. So this is a great way to understand which property is being utilized here? The quotient property. Which one here? The product. Which one right here? The power. This one right here? The quotient. So A and C are the only ones that equal 7 to the power of 6. All right, last one. We have 4 to the power of negative 3 over 4 to the power of negative 1. If I wanted to make it a little bit easier, I could do 4 to the power of 1 over 4 to the power of 3. That's another way of doing it. 1 minus 3 is negative 2, which is 1 over 4 squared. Oh, there's 1 over 4 squared. We got to get 1 over 4 squared. Oh, 4, 1 minus 3. There's another one. It's A and B. That's it.